Hey guys, I'm Mu, and today we're going to be interviewing Miss Ramos, our chemistry teacher from Ronald W. Reagan Senior High School.
So as a science teacher, do you think energy is everywhere?
Of course, the energy is everywhere. When you think about that equation that is very famous because it says that E is equal to M multiplied by the speed of the light to the second power. Anything that is matter contains energy, potential energy. It could be gravitational when we're talking about the position of matter, or it could be chemical. So an apple, it can be that you can have an apple on top of your counter. And when you look at that, you don't think that it's energy in there. Still, you have to eat that to get energy from there because it has chemical potential energy. The wind is matter because it's made of carbon dioxide, oxygen, and nitrogen, and there's energy in there. We were talking about that earlier. You collect that wind, or you move the turbine with the wind, or you collect like a sample of, or the air, and then you can compress that and obtain oxygen from there. That with that you can create energy. Anything that contains matter, it has energy on it. Energy that is stored, or energy that it can be transformed in another type of energy, because according to the law, energy cannot be created, destroyed, only transformed. So everywhere. Right now here, as we are talking, we are surrounded by energy everywhere.
How can we make use of the energy, or like how can we convert the energy is everywhere into electricity?
The main principle, the one that we use here at Turkey Point, we are moving turbines. We are moving turbines using steam. A steam that is gonna be produced after the heat is transferred from cool water, from hot water to cool water. That heat was obtained after the nuclear reaction. Okay, so we move the coil around an electromagnetic field, and then the electrons that are, in that sea of electrons that is on the metal wire, they are gonna flow. That's like the main principle. We need to move the coil in an electromagnetic field to create a flow of electrons. Here at Turkey Point, we do that with nuclear, energy that is coming from a nuclear reaction. But if you think about burning fossil fuel, which is a chemical reaction, a combustion chemical reaction, we do the same. We get the heat from the exothermic chemical reaction, make the steam just to move. So we are using a stored chemical energy, because when you're burning like fossil fuel, is chemical energy stored in the petroleum, the oil. We are using that, burning that, releasing that, and we are converting that potential chemical energy into thermal energy. And that thermal energy then is gonna be converted into the kinetic energy that is gonna produce the electricity or the electrical energy that we use here to power the city, to power all the industry that we have.
Can you give me examples of how we could turn kinetic energy into electricity?
Electricity comes from electrons, so you need a flow of electrons to move. How you gonna make the electron move? Simple. You're gonna expose metal, like coil, metal, to an electromagnetic field. But in order for that electromagnetic field to interact with the coil, or the magnet has to move, or the coil has to move. So the electrons that you have in that metallic bonding in the metal, they're gonna create like a flow of electrons. Now, I was explaining to Diva that it depends. What are you gonna use to move the coil? Are you gonna use fossil fuels? Because when you have steam, the steam is gonna move the turbine to move that. Okay. Are you gonna use wind? Because the wind is gonna move the coil to create that flow of electricity. Are you gonna use, what was the other one? A nuclear power. But the nuclear power is creating the steam, that the steam is gonna move the turbine. Basically, it's the same principle. Motion. You need motion to move the coil around the electromagnetic field. So the source that you're gonna use, it depends. The source. It could be wind power. We were talking about those wind mills that you put on the sea, and that they're using the motion of the tides as well, and the motion of the wave. It depends with what you're gonna move the coil. What makes that more effective, less effective. The only one that makes the difference is the solar power, because you're using the electric effect create that flame. So you are heating the material at a certain frequency to make the electrons jump.
I'm Mu.
I'm Diva, and thank you for watching our video.